Hello, stargazers. Welcome to this episode of Star Trails. I'm Drew, your guide to the cosmos for the week starting July the 28th to August the 3rd. As a follow-up to our recent episode about the Milky Way, we're taking a high-level view of galaxies this week. Later in the episode, we'll take a look at an interesting alignment of the moon and planets you can see this week. So let's get started. Galaxies are immense systems made up of stars, stellar remnants, interstellar gas, dust, and dark matter, all bound together by gravity. They are the fundamental building blocks of the universe, containing billions or even trillions of stars, along with various celestial objects like nebula, star clusters, and black holes. Most of the visible matter in the universe resides within galaxies. From the smallest dwarf galaxies to the colossal giants, these cosmic structures are diverse and complex, each offering a look into the intricate design of the universe. Galaxies are broadly categorized into several types based on their shapes and characteristics. Spiral galaxies have a flat, rotating disk with a central bulge and spiral arms winding out from the center. The disk is often filled with gas and dust, which are active sites for star formation. The Milky Way, our home galaxy, and the Andromeda Galaxy are classic examples of spiral galaxies. They typically have a mix of young, hot stars in the arms and older stars in the central bulge. Spiral galaxies are further classified into normal spirals and barred spirals, the latter having a bar-shaped structure of stars extending from the central bulge. The spiral arms are regions where new stars are constantly being born from the dense clouds of gas and dust. These vibrant regions can appear blue owing to the presence of the young stars that illuminate the surrounding gas. Elliptical galaxies range from nearly spherical to highly elongated shapes. They contain older, redder stars and have little to no gas and dust, resulting in minimal star formation. M87 in the Virgo cluster and M32, a satellite of the Andromeda Galaxy, are examples of elliptical galaxies. These galaxies can vary greatly in size, from small dwarf ellipticals to giant ellipticals that dominate galaxy clusters. Their smooth, featureless appearance and lack of new stars are characteristic. Giant ellipticals are often found at the centers of galaxy clusters and are believed to result from the merging of smaller galaxies. The stars within elliptical galaxies move in random orbits, which contrasts sharply with the orderly rotation seen in spiral galaxies. Irregular galaxies lack a defined shape and structure. They appear chaotic and disorganized, often because of gravitational interactions or collisions with other galaxies. The Large Magellanic Cloud and the Small Magellanic Cloud, both of which are satellite galaxies of the Milky Way, are prime examples. Irregular galaxies often contain a significant amount of gas and dust, leading to active star formation. Their appearance can be particularly intriguing, with regions of intense star formation and peculiar structures that defy easy classification. Lenticular galaxies are an intermediate type between spiral and elliptical galaxies. They have a central bulge and a disc-like structure, but lack the prominent circular arms found in spiral galaxies. M104, the Sombrero Galaxy, and M102, the Spindle Galaxy, are examples of lenticular galaxies. These galaxies contain older stars and little gas and dust, meaning they have little to no star formation activity. Their disk shape gives them a lens-like appearance, hence the name lenticular. These galaxies may represent a transitional phase in galaxy evolution, possibly former spiral galaxies that have lost their gas and dust. The central bulge in lenticular galaxies is similar to that of elliptical galaxies, while the disk component resembles that of spirals, though without the vibrant star-forming regions. Galaxies are not static structures. They're in constant motion, traveling through the expanse of space. Their movements are governed by the gravitational forces exerted by other galaxies, dark matter, and the overall expansion of the universe. This complex dance includes several components: the rotation of the galaxies themselves, their interaction with nearby galaxies, and their journey through the cosmos. Within a galaxy, stars and other celestial objects move in orbits around the galactic center. In spiral galaxies, the stars in the disk follow roughly circular paths, while those in the central bulge and halo often have a more elliptical orbit. The rotation curve of a galaxy, which plots orbital velocity against the distance from the center, provides crucial insights into the presence of dark matter. Observations show that the outer regions of spiral galaxies rotate faster than can be accounted for by visible matter alone, suggesting the influence of an unseen, massive halo of dark matter. Galaxies also move relative to one another, influenced by their mutual gravitational attraction. This can lead to a variety of interactions, including close encounters, collisions, and mergers. When galaxies collide, their stars generally pass by one another due to the vast distances between them, but their interstellar gas and dust can interact violently, triggering bursts of star formation. Over time, such interactions can reshape galaxies, creating tidal tails, rings, and other complex structures. The Milky Way itself is on a collision course with the Andromeda Galaxy, with the two expected to merge in about 4.5 billion years. Galaxies are also part of larger structures within the universe, such as groups, clusters, and superclusters. The expansion of the universe, described by the Big Bang Theory, also affects galactic motion. As space itself expands, galaxies recede from each other, a phenomenon observed as the redshift of distant galaxies' light. This expansion is accelerating, possibly because of dark energy. Backyard astronomers have the opportunity to observe some fascinating galaxies this time of year. The Andromeda Galaxy, our nearest spiral galaxy neighbor, is a must-see. Located in the constellation Andromeda, about 2.5 million light-years away, Andromeda is visible to the naked eye from dark sky locations as a faint, fuzzy patch. With binoculars or a small telescope, viewers can see its bright core and elongated disk. Andromeda is best observed in the late summer and autumn. The Whirlpool Galaxy, or M51, in the constellation Canes Venatici, is a stunning face-on spiral galaxy approximately 31 million light-years from Earth. Known for its well-defined spiral arms and interaction with its smaller companion galaxy NGC 5195, M51's spiral structure and the connecting bridge of material can be seen with a moderate-sized telescope. It's best viewed in early summer evenings. The Sombrero Galaxy M104, located in the constellation Virgo, is renowned for its bright nucleus and prominent dust lane, giving it a wide-brimmed hat appearance. This lenticular galaxy is about 29 million light-years away and visible through small telescopes. Its distinctive shape and dust lane are best observed in the southwestern sky during early summer. In the constellation Triangulum lies the Triangulum Galaxy, M33, a beautiful face-on spiral galaxy about 3 million light-years away. While challenging to see with the naked eye, it can be spotted with binoculars or a small telescope. Under dark skies, its spiral structure becomes visible, making it a fantastic target in late summer and autumn. M82, the Cigar Galaxy in Ursa Major, is undergoing intense star formation, giving it an elongated, cigar-like appearance. Located about 12 million light-years away, M82 is relatively bright and can be seen in a small telescope. It's best viewed in early summer nights when Ursa Major is high in the northern sky. Another highlight is the Pinwheel galaxy M101, also in Ursa Major. This face-on spiral galaxy about 21 million light-years away showcases grand spiral arms filled with star-forming regions. A moderate-sized telescope will reveal its spiral structure and bright core, making it a nice sight in the early summer sky. Additionally, Bode's galaxy M81, also in Ursa Major, is a bright spiral galaxy alongside the Cigar galaxy. With a bright core and well-defined arms, M81 is an excellent target for small to moderate-sized telescopes in the northern sky during early summer. Now, let's check out what's happening closer to home. This week, the moon will transition from its last quarter phase into a waning crescent by midweek. The new moon arrives by the week's end, providing darker skies ideal for observing celestial objects such as galaxies and nebula. Remember, we're keeping an eye on the constellation Corona Borealis as we're still awaiting the highly anticipated nova of T Coronae Borealis, also known as the Blaze Star. This recurrent nova has a history of outbursts, with notable eruptions in 1866 and 1946. TCRB typically clocks in at a dim magnitude of 10, but it could brighten to magnitude 2 or 3, making it easily visible to the naked eye. That's about as bright as Polaris, the North Star. Astronomers are watching closely for the next nova, which could happen at any time. The Moon, Mars, and Jupiter will be putting on a show for night owls this week. Look eastward in Taurus in the early morning hours after 3 a.m. to find the slender crescent moon only about 5 degrees away from both Mars and Jupiter. During the closest approach on the morning of July the 30th, the moon will be just above and to the left of the red planet. Look for Jupiter at a bright magnitude of nearly -2, just below the moon. Jupiter will also be to the left of Aldebaran, the red giant that forms the Eye of the Bull in Taurus. Uranus will also be in the vicinity very close to the Pleiades, about 10 degrees to the right. You'll need at least a good pair of binoculars to locate it. Saturn remains near the knee of Aquarius in the east. It begins its march into the sky around 11 p.m. and ends up high in the sky just before dawn. This is a perfect time to see the delicate, nearly edge-on orientation of Saturn's rings. As the planet rises higher in the sky, it moves away from the atmospheric turbulence near the horizon that interferes with telescopic views. Neptune is close to Saturn above and farther east near Pisces, but you'll need a telescope to see it. Venus and Mercury are evening planets. They're beginning to distance themselves from the Sun, so you may have a good chance of catching a glimpse of them low on the western horizon just after sunset this week. Venus sets not long after the Sun, but Mercury hangs out a little while longer. Try to catch both around 9 p.m. Keep in mind the viewing window for the Perseids is open now, so you may be able to catch some meteors during your observations. The shower is expected to peak around August 12th. That's it for today's episode of Star Trails. Before you go, I invite you to check out our weekly email newsletter on Substack, where you can receive night sky reports and astronomy news that we don't always mention on the podcast. It's completely free and a great supplement to the show. We're also on Mastodon at *_trails, and we'd love to hear from you. I'll include links to both services in the show notes. Also, remember our website, startrails.show, where you can find all of our episodes, including transcripts. Until next time, keep looking up and exploring the night sky. Clear skies, everyone.